This topic is most useful topic in Verilog because you will use it many times in your test bench as well as in your code. So let's start. So parameter, as you can see, a parameter is like you can just assume for now at the start of video as a constant. So a parameter in a Verilog is a compile time constant, means some value or any value you can give with help of some word like width or length or anything, any parameter you can understand, pi, theta, anything, some variable we are assuming and giving it value in our code. So used to make a hardware models configurable and reusable. So why we are making this word there? Because we can change that value of that word, means value of that parameter anytime. Therefore it is parameter. Now we can change it. Now it is not runtime variable. As you can see, this is during compile time, because your hardware will be created in compile time and we will run that in your simulation. That is the runtime. So parameter should be defined previously. For example, if you have created some memory, let's assume it is a memory. So in compile time, we don't know what is the width and what is the our depth of this memory. Okay, but for now let's say 3 or 3 is a width and length. Okay, width and depth, whatever you can say. So this thing and this thing, we will give this value like 5, 3 and 3 in our compile time with the help of parameter, and this parameter can be theta or alpha, any way you can, L, W, whatever you want. Now this parameter we will write in code and give this value 3, and in this thing will happen in compile time, and this thing when happens in compile time, your memory will be created, and in runtime we will use this memory. Simple. Now its value is fixed when the module is elaborated before simulation. So before simulation only we will give this value 3, and how we will give value and what we will do, we will see in our next slide. Or
hit subscribe, like, and comment now. Let's begin the journey of verification.
So now another question, why do we use parameter? So these are all the things why we use our parameter. Because reusability, as we can say, a memory is there, you have created in previous slide, that same memory is 3 by 3, but now your code changes and you want 6 by 6, so you can change the theta and alpha parameter. Okay, therefore we take theta and alpha. We can directly give 3 3, but we want to change the theta alpha to 6 by 6 memory. Okay, this is 3 by 3 memory, or this is 6 by 6 memory. Okay, so you can reuse that same parameter and you don't have to change the whole code. Configurable, customize hardware without modifying the code. Similar thing, if this is memory as a hardware, you can customize it to 6 by 6 in your code. Easy upgrading, change size in one line. Any parameter, whatever you have declared in array, in queue, you can change it afterwards. And RTL flexibility, because we are in software, so we need flexibility for changing your code in every way. We have to check, for example, if version 1 has 16-bit, if this 16-bit is in version A, now in version B or 1.2 version you will have 32 bits. In industry mostly we will write a code in version 1.1, 1.2, it is get updated every time. So if it changes, then parameterization is must used concept, or very important concept. So here is the syntax. So here syntax is for this width count, it is a variable. Here it is our module. Inside our module we are just changing our width with the help of our parameter, and wherever you will see this hash thing before your ports, we use this hash and whatever parameter you need inside our module. This thing will change our count as a width. -1 -1 is like, for example, if it is 7:0, means it is 8, total size is 8 bit. Okay, so this is width -1, so 8 minus 1, it is 7:0. Okay, then it is 7:0, and you will get your count as a 7:0, 8 bit. And whenever you want to change, I will tell you two ways to change the values of this with parameter without using the actual module. We will change with the help of test bench. Okay, so this is the simple syntax. You can just include your parameter hash parameter, and you can give this to any variable. You can write this parameter inside the module as well, like you can write here parameter and equal with like this. You can write here as well, but if you want to change in runtime or means compilation time, then you have to write here. So where can the parameter be used? First we will answer this question, then we will change the value of parameter. So where can parameter be used? Port width. The previous example port width we have used. Register size, as I said, second example like it is module, and inside that if you want any array or any, you can change the parameter. Simple thing, if a is 1:0, then you can write a for example p for parameter -1:0. This thing you can do anywhere you can change this value parameter. Memory dimension, for example this is memory, the simple thing, one another bracket will come and a is to 0, a -1:0. This is our memory then. Okay, loops limit, for loop, and you have understood the loop thing in many languages, the same thing. Computation and constant expression. Okay, now if you have written a function, and you have some kind of thing, and you want some or any expression, you can say any expression, and in expression you need a variable, for example pi. You can just write the parameter pi here and into whatever you want, into a or anything. So this function, this computation will be done every time this function will use this pi value. So this kind of thing, constant expression. So this is also same example. If you just want to write an exception inside your always block, you can use this thing. So wherever you want or play with the parameter constant values, you can say, or you want to change the memory width or anything, wherever you are using constant numbers, whenever you are using the numbers, you can change that number with the parameter, and you can change that number anytime with the help of your test bench. Okay, now types of parameter in Verilog. Because of this I haven't explained you what is our changing, how to change the thing. After this we will change the values of the parameters. Okay, so module parameters, default values that can be overridden during instantiation. Okay, so we are using here parameter keyword. With we can change this thing we can change parameter, but local parameter, for example inside your design, designer want that you should not be able to change the parameter with the help of test bench. This is test bench. Okay, you designer what you cannot change this value, so he will use local parameter like adder width. If some adder inside the design, it should be 4 width, and you don't want to change that with the help of test bench, so we will use this local parameters. Usually initially internally in module cannot be overridden. Okay, so you use local param as a keyword. Okay, these two types of things are there. Now here is how to change the parameter. There are two ways, one is old, one is new. So first we will see the new way. Just like counter hash dot width, in counter you have written that width, right? You can just directly change with hash width dot width, it is named instantiation, and with hash you can explain that it is parameterized template. Okay, and your width variable will be changed here. Old style is like you have to write this defparam in your test bench, then you have to write the variable name c1.width, and you have to change this thing. So it is writing a different thing, but for example different code for changing the width value. But in this case you are just instantiation of this counter in your test bench. This is test bench, simple instantiation there, but only this hash width 8, this thing is added inside your instantiation of your module. So it becomes simple, right? You just have to instantiate with the help of your parameter. Okay, these things are done. This is only thing for the parameters. You can practice it. In near future I will create some projects for your Verilog course, and you want any content related to Verilog, you can ask me any advanced concept. I will create videos in future just covering all the basic. Okay, thank you.
Please Lord give me a sign, a sign.